Okay, so we have a proton um, that has a quantum property called spin. And while we can think of it as spinning, it's not really spinning, it's just a quantum property of the proton. It has a magnetic field due to this quantum number to its spin. And the field is similar to that created by a current loop. And so we can imagine it as a current loop of 0.65 times 10 to the minus 15th meters in radius, a current of 1.5 times 10 to the fourth amps. That's kind of high, right? Find the maximum torque on the proton. This is very similar to the last problem. We're just trying to find out what is the maximum torque it can be, which is when the magnetic field and the spin of the proton are in fact perpendicular to each other because it's a cross product, right? So, the fundamental torque equation is mu cross B, and we know the magnitude of the mu is given as NAI, and the number of turns times the area times the current. Well, the number of turns in this case is 1, so we're just looking at pi times this radius squared times the current. Just note out here n equals 1, right? Pi r squared is the area, a very small area. The current's very high. So we're going to get mu from this. We have the magnetic field of 3.64 Tesla. And so, and the torque is maximized when they're perpendicular. So that'd be pi r squared I times B, right? So pi times 0.65 times 10 to the minus 15th meters squared times the current 1.05 times 10 to the fourth amps times the magnetic field 3.64 Tesla. All right. Okay, so let's go calculate this and see what it is. So we've got 0.65 E minus 15, 1.05 E4, and 3.64, right? So we've got pi times radius squared times current times magnetic field. So 5.07 times 10 to the minus 26, and state your answer is a factor of 10 to the minus 27. So we're going to take this and divide it by 10 to the minus 27, and that's going to give us 50.7, right? So tau is 50.7 times 10 to the minus 27 Newton meters. All right, 50.7 times 10 to the minus 27 Newton meters. All right, that's it for problem 8.